Alrighty, welcome back, boys and girls. It's your main math man, Mishank, coming to you live from Summit Academy. In this video, working on that unit number 8, and then we're working on that lesson number 6. Still talking about these triangles and kind of piecing towards it and starting to work with the Pythagorean theorem. For this one, this is the think pair share. It says which triangle does not belong. So pause the video, work with your partner, try to pick one or two triangles and write why you think that they don't belong compared to the other triangles. On this second part, it looks like this. It says complete the tables for the 3 triangles. So it gives you the triangles D, E, F. And what you're trying to do is you're trying to find the side lengths first. So similar to what we did before, we can kind of say if we draw that draw that tilted square first, something like this. Again, we've been practicing this for a while now, so it should be pretty good with it. So we have that tilted square, and what we can do is we can find the big square around it. We can say, well, if this is the big square, we can find the area of that big square, find the area of the small triangle, and then take the difference. So it would be like this. I'd say the area of a big square is going to be 4 times 4, which is 16. The area of the triangle is going to be, let's say, 3 times 1 divided by 2, which is 1.5. Take 4 times that amount. So we do the area, let's say 4 times that area of a triangle is going to be equal to 6. So that means the area of my tilted square is going to be 16 minus 6, which is just 10. So that means the side length of one of these, this tilted square, is going to be that side length C, which is the square root of 10. For the other ones, I can count this side length A. That one's real simple. That's just going to be 2. So that side length of A is 2. And then the side length for B, you can do that same thing, but it's going to be the square root of 2. Same idea with the others. Let's say if we have, for that triangle E, if we have the side lengths is 2, 1, and square root of 5. And we have, for F, a little bit trickier, but we can still find it. It's going to be 2, square root of 5, and square root of 5. So make sure you're seeing how that works. So now for the second part, it says to complete the table. And now, since we have these side lengths, what we can do is we can square them to get our new side lengths, or the areas of those big squares. So we're going to say 2 squared is 4, square root of 2 squared is just 2, and square root of 10 squared is 10. Same idea with this one. We're going to say this is going to be 4, this is going to be 1, and this is going to be 5, because we have 2 squared, 1 squared, and square root of 5 squared. So that means this is going to be 4, 5, and 5. So then it says for number 2, it says, what do you notice about the values in the table of the triangle E, but not for the triangles D and F? Well, I can say this. Let me kind of write this down real quick. So it says, I can say the sum of A squared equals 4, and I can say B squared equals 1. So that means if I take the sum of these two squares, let's say that it equals C squared, which is equal to 5. So if I look at those, 4 plus 1 equals 5. Notice how that works only for E, where the other ones 4 plus 2 is not 10, and 4 plus 5 is not to 5. So it only works for that triangle E. All right, similar idea. It's just complete tables for those 3 other triangles. So same kind of setup. Find the square roots, or find those side lengths. So I'm going to say, if I can give you some of these, I can say if this is, double check one more time, yeah. So if this is, let's do in blue again. I can give you these side lengths. So this is going to be 2, this is going to be square root of 5, square root of 13. This is going to be 2, 3, and square root of 13. And this is going to be 2 square root of 10 and square root of 10. So that same idea, we can keep going and say, well, what's the squares going to be of those side lengths? So what we can do is take and square each of these values. So I have a squared is going to be 4, b squared is going to be 5, and c squared is going to be 13. So make sure you're kind of seeing how those work. So we said 2 squared equals 4. We had square root of 5 squared equals 5. Inverse operation, so we just have 5 left over. And same idea with the square root of 13 squared, that equals 13. So that's what I'm doing when I'm getting from this first table to the second table. For this one, for Q, I have this is going to be 4, this is 9, and this is 13. And then we have for that R, we have 4, 10, and 10. So it says underneath that, or at the bottom of your page, it says, what do you notice about the values in the table for Q, but not for P and R? Well, same kind of thing what we did before. We said, we could say the sum of a squared is equal to 4, and we know that b squared is equal to 5. So the sum of these two values, or sorry, not 5, it should be 9, sorry, 9, I was looking at the wrong one. So b squared is 9, the sum of these two values equals, let me write it, equals 13, which is c squared. So notice how it has a squared plus b squared equals c squared, which is what we're going to be talking about here shortly. And then it says, what do you notice about that triangle E and that triangle Q? Well, we can say what type of triangles they are. We can say they are both right triangles. And that just means that they have that 90-degree angle in them. So that just means 90-degree angle. All right. So notice how for each of those right triangles, we said that we could use that a squared plus b squared equals c squared. So on the back it says, meet the Pythagorean theorem, which is exactly what that is. It says, find the missing side lengths, and we'll be able to explain how we got those. So in that first one, this one's a little bit simpler. We can count this side length because it's just a straight horizontal line. So we can say this is going to be a side length is 4. And I could say, hey, I know that this is an isosceles. So isosceles triangle. That means that the other side lengths are equal. So I can have A and B are both equal. So that means B is going to be equal to the square root of 8. For the next one, I can say for R, same idea. Since it's a vertical line, I can just say, well, I know that this side length A is also going to be 4, and so that's the only missing side length. And then for Q, same idea as we did before. We can say that we can draw our tilted square again. let's do it like this. So how many times is that? We got 1, 2, 3, 4, 5, 6, 7. So let me count. I have 1, 2, 3, 4, 5, 6, 7. 1 to the right. 1, 2, 3, 2, 3, 4, 5, 6, 7. That should give us those lines. Let me try drawing the straight lines like so. And something like this, maybe. Okay, so we have our tilted square. And now we're saying, okay, draw the big square around it. So we can say, all right, we have this big square around it. Just like we've been doing, find that area of the big square. Find the area of the small triangles. And then take the difference of those two. So I can say it like this. I can say, all right, I know the, let's do it over here. I can say the area of my big square in purple is how long is the side length? Well, it's 1, 2, 3, 4, 5, 6, 7, 8. So I have 8 squared, which is 64. Find the small triangle. So I can say, let's draw it like here. Find the area of this triangle. That side length is 7. So I can say the area of the triangle, the green triangle, is 7 times 1 over 2, which is just 7 over 2. And then I can say, well, I need to find 4 times that amount. So I do 4 times the area of the triangle is equal to, what was that, 14. Take the difference of these two to find the area of my tilted triangle. Tilted square. So tilted square. So I do 64 minus 14 is 50. And I find the side length. So I say side length is going to be equal to the square root of 50. And that makes sense too, because if we think about this formula that we have a squared plus b squared equals c squared. So we could say this. Let me try fixing this real quick. There we go. Okay. So we're saying which triangles work for it? Well, they only work for those right triangles. So we're going to say this works for triangles P and Q. And that works because Q is a right triangle. Notice how it has the right triangle symbol there. P is a right triangle because it has it right there. However, R is not a right triangle. So that's a way we know as well. A way we can check it out to see if that is actually true, if we take if I look at Q again still, if I say, let's say if we have square root of 10 squared, or sorry, square root of 10 squared plus other side length is square root of 40 squared, that should equal the square root of 50 squared. And that makes sense because 10 plus 40 is equal to 50, so that does work out. All right, so for the practice, it says here is a diagram of an acute triangle and 3 squares. It says Priya says that the area of a large unmarked square is 26 units because 9 plus 17 is 26. Do you agree? Explain your reasoning. So we're going to say for this one, let's change this up. Let's say for this one, no. We're going to say no. The Pythagorean theorem only works for right triangles. So only works for right triangles. And we know this is not a right triangle because it had that word acute in it, so we know it can't not be a right triangle because it doesn't have any right angles in it. So that Pythagorean theorem only works for right triangles. For number 2, it says M, P, and Z represent the lengths of these three sides of a right triangle. It says select all the equations that represent the relationship between M, P, and Z. You gotta be careful in this one because we know if we were to label it out, again, the hypotenuse is opposite of my right angle, so I'm going to say this is our hypotenuse, and these are the legs. So that means when I have a squared plus b squared equals c squared, that means I have the legs. I have a leg squared plus a leg squared equals the hypotenuse squared. So I have to make sure that I have I have the hypotenuse, which is m. I have the hypotenuse m on the equals side. So that means this. If I look at these first two options, again, find where m is at. Since m is not all by itself, I know these two are not right. However, with these other four, I notice that it says equals m squared, so each of these are good. So each of those four are good. And then for, let's say, number 3, it says the lengths of three sides are given for several right triangles. For each write an equation that represents or expresses the relationship between the lengths of the sides or lengths of the three sides. So you have to be careful in this one because we have to say that the hypotenuse equals longest side. So if you're unsure about these, I should be able to say, well, again, this is going to be C. Let's have, careful there. Let's say this length is going to be equal to C. We have square root of 30 is the longest side. Square root of 30 is the longest side. We have square root of 37 is going to be the longest side. And we have for this one that 3 is going to be the longest side. So now that we have those, we can kind of write our equations like this. So I'm going to say, again, I have the first one, I can have 6 squared plus 8 squared equals 10 squared. So you're saying, and each of these, we're just saying 2 of the legs, each of those squared equals the hypotenuse squared. For the second one, we have the square root of 3 squared plus the square root of 5 squared equals the square root of 8 squared. So it gets a little messy in here, but that's okay. As long as we know that the hypotenuse is that longest side, we'll be good. Same idea with the next one. We could say this is going to be 5 squared plus square root of 5 squared equals the square root of 30 squared. So we're just setting these up so that way we know what these equations should look like. For the fourth one, it says we have 1 squared plus 6 squared, which is equal to the square root of 30 squared. And lastly, but certainly not leastly, got square root of 2 squared plus our square root of 7 squared is going to be equal to 3 squared. Again, each of these we can check to make sure it works, but it should always go back to our general formula for the Pythagorean theorem. Be sure to ask questions for yourself, and as always, super slam that subscribe button.